Hello.
Hello, sir.
Yeah. Good evening to you all.
Yeah, good evening.
Yeah. Now we'll start our lecture by 6:05 or 6:06. Okay. This will be lecture live lecture number 8. Okay. Good evening to you all. This is the live tutorial classes, week 8. Okay. Myself Subrata Kumar Maiti, PhD students from IIT Roorkee. The subject is here for hydrogen energy, that is the production, storage, and transportations and safety. Okay. So far, so on, we have discussed in the last previous few live sessions, that was the productions, and now we are on the way of storage. Next, we'll coming on the transportations and safety part. Okay. As far as we have discussed the hydrogen storage systems, we have studied different tank. Okay, different tank, I mean type 1 tank, type 1 tank, type 1 tank. Do you remember what is the type 1 tank? It is totally made of metallic body. Okay, it may be a cylindrical body, cylindrical shape body. The total cylindrical shape is kind of metallic surface or metallic made of material or made of metal material. Okay, next is the type 2. Type 2 means that the hoop positions means that these positions, hoop positions, because you know that the hoop stress and longitudinal stress is much higher. That's why we can covered, or we can given such we can given much more strength to the hoop positions. Okay, that is the type 2 tank. And type 3 tank, type 3 tank is basically, it is total covered. Inner position is the metallic body. Okay, outside is covered by the total is the another material covered. This will protect our, and this will give some strength to the hydrogen storage tank. Okay, this is the type 3 tank. And type 4 tank is what? Now we will discuss in details here in the type 4 tank. Here is the two layer. One is the upper side layer, upside layer, and another one is the inner layer. Inner layer is the made of the polymer. Okay, high strength polymer. Okay, and in between the two tank, in between the two seat, or in between the two layer, there is the insulations. What is the purpose of the insulations? Here we'll store the liquid hydrogen or low temperature hydrogen or cryogenic hydrogen. Here always the main purpose will be of insulating this tank is to just to minimize the heat loss from the cylinder or minimize the heat loss from the liquid hydrogen. If we can't control the heat loss from the liquid hydrogen, then it will be heated up and the boil off will occur. Okay. And some other accessories like pressure sensing, some tank regulating valve, refueling port, and vent line. These are the available in the Type 4 tank. Okay. The two or three more important part is the pressure release valve. What is the function of the pressure release valve? That somehow if the pressure inside the cylinder will increase, then drastically it will reduce the pressure by opening the pressure release valve. Okay. Refueling port, you know that during the hydrogen fuel refuel time, then this port will come into action. Okay. This is the basic constructions of the Type 4 tank. Okay. Some pressure sensing device is also accommodated there because according to the pressure release valve and other accessories, other valve will open and close. Okay. And what is the setup valve? Some other valve is also there. One is the setup valve. This all the valves are accommodated here because just to safety purpose. Okay. This is also setup valve is also designed for the safety to stop or continue the flow of hazardous fluid or from the external side, or some hazardous gas will be out from the cylinder. The history of liquefations you can study or you can go through. Okay. This is the important part. Will coming that the challenges in the hydrogen liquefations. The challenges of the hydrogen liquefations, generally at atmospheric conditions, hydrogen is gaseous conditions. But during the liquefations, temperature should be at 20 Kelvin. It is a very low temperature than the atmospheric temperature. It is a very lower temperature because at such a low temperature, we have to protect this gas. Otherwise, some heat losses will be there and it will make some hydrogen gas or hydrogen gas bubble. It will create some more pressure inside the cylinder. Then the cylinder may burst. Okay. The you should know the boiling point of the hydrogen, that is the 20 Kelvin. Okay. Remember the temperature of the hydrogen boiling point. And the main challenges also that the ortho to para conversions, that is the during the ortho to para conversions, we know that for the ortho hydrogen, the energy state of the ortho hydrogen is very high than the para hydrogen. At lower temperature, what happens that this ortho hydrogen will convert into the para hydrogen. Okay, that means ortho hydrogen is very higher energy state. This is the higher energy state. This is the higher energy state, and para is the lower energy state. Lower energy state. When the conversions will occur from the ortho to para, ortho hydrogen to para hydrogen, what happen? As it is higher energy state, some energy will release. That's why it is called exothermic reaction. Exothermic reactions. Some energy will release. Okay. And during this ortho to para hydrogen conversions is very slower process unless we use the catalyst. This conversion is very slower process. Somehow, if some ortho hydrogen is stored into the cylinder, what will happen? Slowly, this ortho to para hydrogen conversions will occur inside the cylinder. and it will generate some energy during the conversion process. This energy will help for boil of the hydrogen. Okay, during the boiling of the hydrogen will convert the liquid hydrogen will convert into gas, and this gas is in higher pressure state. Okay, and this high pressure state, if this high pressure comes into the cylinder, inside the cylinder, this pressure may rise the inside pressure of the cylinder, and this cylinder may fail. So during the design considerations, you have to keep in mind that the how much pressure it can sustain. According to that, the material and the design shape and size will be considered. Next is the inversion temperature of the hydrogen is below ambient condition, ambient temperature. What is the inversion temperature? I will discuss.
Sir,
Yeah.
these during the design, so how much we should consider that this ortho percentage of ortho will remain, and it may later on form to para, so that the design pressure of the tank will be
Should be
done.
safe. Actually, what happened? Suppose you have one cylinder.
Is my
Yeah.
question clear?
Yeah. Very much clear. Suppose you have one cylinder. Before entering into the cylinder liquid hydrogen, you have to assure that all of the hydrogen have already converted into the para hydrogen. Okay. Unless what will happen, you know. Okay. So just before storing, you have to check this hydrogen is in which state. It is in ortho state or para state. You can measure this ortho state or para state by using different technique. Okay, like some energy measurement technique. You can also measure the other technique, other spectroscopy technique. Okay, or some energy technique like that. You have to measure the what is the energy state of the hydrogen. Okay, suppose 1 kg of hydrogen, 1 kg of hydrogen. Suppose 800 gram of hydrogen is in ortho state. Sorry, 800 gram of hydrogen is para state, and 200 gram of hydrogen is ortho state. That means this 200 gram of para state ortho state hydrogen will convert later into the para state. Okay, that will release some energy. Okay, and how you will measure the this hydrogen is in combinations of the ortho and para. Okay, if you measure the total energy, total thermal energy or total energy, kinetic energy of this hydrogen, you will get some higher energy. In case of if you have 1 kg of hydrogen with para hydrogen, 1 kg of para hydrogen, obviously you will get, if you measure the energy, you will get the low energy content. But 1 kg of hydrogen if contain 200 gram of orthohydrogen, the energy content will be higher, such that you can understand that this hydrogen what you are going to enter into the liquid hydrogen tank, it is not suitable for storing. You have to convert from ortho to para. How we will convert from ortho to para? There is some reactions. Okay, by using the catalyst you have to convert it from ortho to para hydrogen. Okay. Okay. Now is the inversion temperature of the hydrogen is below the ambient. Okay. What is the inversion temperature of the hydrogen? Anyone of you know? This is minus 68 degrees centigrade. That means 200 Kelvin. Okay. If you calculate, this is 200 Kelvin. What is our atmospheric temperature? Atmospheric temperature is 3, sorry, 273, 273 Kelvin. The inversion temperature of the hydrogen is 200 Kelvin. So whatever the gas you have, if you want to compress this gas, you have to assure that, or you have to make this gas should be gas temperature should be below 200 Kelvin or below 68 Kelvin, 68 degree centigrade or 73 degree centigrade, minus 73 degree centigrade. Okay. Uh, this is the ortho to para conversion energy release. When the ortho will convert into the para.
Sir, this inversion temperature. So,
Yeah.
can you please again explain what is the inversion temperature?
Yeah.
We
Yeah.
understand that H2 for H2 hydrogen
Yeah.
gas inversion temperature is minus 68 degree centigrade or 200
Yeah. Yeah.
Kelvin.
200 Kelvin.
So, what is this inversion temperature? What is the
Yeah.
meaning of that?
Yeah. I will explain. Just in the next slide, I will explain. Okay. Just just patient. Be patient. What the important things is here, you have to remember some values like what is the if the suppose one atmospheric conditions ATM conditions, you have some hydrogen. What is the percentage of the ortho and para hydrogen? That is the ortho hydrogen percentage is like 75% and para hydrogen percentage is 25%. Okay. But whenever in the liquid conditions, whenever the liquid conditions, the this you have to convert this ortho hydrogen almost 99% or 100%. Okay. Then only you can store. Okay. What is the energy releases from the conversions? The complete conversion from the ortho to para. The complete conversion from the ortho to para, I means you have 100% ortho hydrogen. If you want to convert from ortho to para, 703 kilojoule per kg, 7 this much of energy will release. Okay. This mass of energy will release 703 kilojoule. And if you have atmospheric conditions hydrogen, that means 75% hydrogen ortho and 25% para hydrogen. If you want to convert this atmospheric hydrogen, this will release 527. This will release 527, 527, 527 kilojoule per kg. Okay. This so much higher energy is higher than the latent heat of the vaporizations of hydrogen. That means during the release time of energy, this energy will help to vaporizations of the hydrogen. So some part of the liquid hydrogen will evaporate. When the evaporations will occur, what will happen? The evaporation latent heat of evaporations will happen. That means the it will generate some gas inside the cylinder, and this gas will be at higher pressure. This high pressure will generate high pressure to the cylinder wall such that cylinder wall may fail. Okay. This generations of the hydrogen gas from the liquid state, this is called the boil off. We have to restrict this boil off. How we will restrict this boil off? There are the different steps you have to take care. Okay. Or you have to minimize these evaporations. Okay. Okay. Now I am coming to the acha. During the throttling process, no. During the hydrogen gas, H2 gas, hydrogen gas, our main objective is to store liquid hydrogen or store liquid hydrogen into the hydrogen cylinder. Okay. Why? What is the main purpose of the liquid storing into the liquid storing into the cylinder? Because we can accommodate larger amount of the hydrogen or specific energy will be high for the liquid hydrogen. That's why we always want to store it into liquid phase. Okay. This is the liquid conditions. I think all of you aware that before converting it into liquid, there are three steps. First step is the compressed compression compression of the hydrogen gas, compression of the hydrogen gas. That means from suppose 1 atmospheric pressure, 1 bar 1 bar to 200 bar. This is the compression process, BAR. This is the compression process. Second step is the cooling process, okay, or chilling, COOLING. Second step is the cooling process. My writing is visible. This color is quite mixing with the background
Yes,
color.
yes, writing is
Okay.
visible.
And third process is the throttling process. That means expansion process, throttling. Throttling process, or it is called expansion process. Why we are doing the compression state, or why we are going for the cooling purpose? Because this cooling purpose just because of lowering the temperature below the inversion temperature. I will come the definitions of the inversion temperature. Just to remember that this cooling process is done only to make sure that the hydrogen temperature is below the inversion temperature. Otherwise, you cannot be successful for making liquid from the gaseous hydrogen to liquid hydrogen. Okay. Why the compression is needed? Because compression process is needed because we have to go throttling process. So you should understand the throttling process, cooling process you know, and compression process you know. Compression process is a very simple process that by using the cylinder or by using the piston cylinder arrangement or reciprocating arrangement, you can compress the or you can make the hydrogen gas pressure high from the atmospheric pressure to higher pressure. Okay. Now you have to understand that the throttling process. What is the throttling process? The throttling process, I think all of you ever the throttling process in your home, all of you are using the refrigerator, AC. There is a one device, throttling device. If you carefully notice just backside of the refrigerator in your home, you will see one, this is the pipe. Inside the pipe refrigerant is flowing, and there is a one device like this shape. It is a larger size, it is a slightly larger pipe dimensions, then the pipe dimensions is very reduced. Okay. Okay. What is happening here? The compression state, if suppose you have this hydrogen gas, very large amount of the compressed hydrogen gas here, and here is the throttling device or some porous material or throttling device. Suppose this is the case. This is your pipe. Here is the compressed hydrogen gas. Here is the compressed hydrogen gas. Okay, you have compressed hydrogen gas. Pressure is P1. Suppose pressure is 200 bar. Here is the throttling device. Throttling device is means that the one restricting device. That means this higher compressed gas, you will allow very small quantity of the compressed gas, and this will expand here. Okay, this is throttling process. Means that the you will not allow full flow of the compressed hydrogen gas. You have to restrict by using one throttling valve or any kind of valve, such that a very lower flow rate of gases will come and it will expand. Okay, understand? That means when the it is expanding, that means pressure will be less. So suppose pressure will here 10 bar. So P1 is greater than the P2. This is basically throttling process. During this process, what happen? For the ideal gas, for the ideal gas, for the ideal gas, for the ideal gas equations, you know that the PV equals to nRT. nRT. What happen? What happen in the temperature? For the ideal gas, temperature will rise, temperature will decrease, temperature will constant. What is your answer?
Temperature will remain same.
Exactly. Temperature will remain same or temperature will be constant. Temperature will be constant. What for the real gas? But for the real gas or real condition. But real conditions, what will happen?
So temperature basically reduce. It may increase also depending on the inversion temperature.
Exactly. Just I am coming. Yes. Some other student is waiting. Okay. Okay. For the real gas, the temperature may rise or may increase. Temperature may rise or temperature may decrease. Temperature may decrease. It will depend on the throttling coefficient. Okay. Or Joule Thomson coefficient. Okay. Another thing, in the throttling, it is isothalpic, isoenthalpic. I means that the enthalpy will remain constant. Enthalpy will remain constant. That means that the inside temperature or positions 1 temperature at positions 1 and after before throttling 1 and after throttling 2, total energy is same because we know that the unit of the enthalpy is the kilojoule per kg. That means simple means that the how much energy contained in 1 kg of hydrogen or 1 kg of any liquid or any gases. Okay, that means we are not changing the energy from the before throttling or after throttling. That means what is the conditions, what is the thermodynamic situations here? This is the we are we are not adding any heat before and after the throttling. That means the this is the adiabatic conditions. Okay, because we know that the in the adiabatic condition there is no heat added or released from the system. This is so throttling process is the adiabatic conditions. Adiabatic adiabatic conditions. Up to this, I think it is clear. Why I have writing that this is isothalpic process. That means H1 equals to H2. Okay. Next. Okay. Uh, okay. I have to use one different extra sheet. Next, I am coming to the inversion temperature. So far, I have discussed during the throttling process. During the throttling process, this is adiabatic condition, adiabatic, adiabatic conditions. So H1 equals to H2 and higher pressure liquid or higher pressure gas is expanding. That means P1 is higher and outlet pressure will be lower. It is okay. These are the condition I am writing here. Okay. Is it clear? Okay. But what is the inversion temperature? I have told you that the before throttling of the hydrogen temperature should be below the inversion temperature. Suppose this is the throttling device. The temperature of the hydrogen should be below the inversion temperature. I mean, temperature of the hydrogen temperature should be below the inversion temperature. Temperature inversion INV, that is quietly 200 Kelvin. Okay, this is the throttling device, throttle. Okay, what is happening if you draw the temperature versus pressure? Okay, acha. During the throttling, the temperature may rise or temperature may decrease depending upon the conditions. Okay, if you draw the temperature versus pressure, okay, the curve will be like this. Uh, Curve is like this. So one peak temperature point is there. This temperature is the inversion temperature. This peak temperature is the peak point is that inversion temperature. This line is the isoenthalpic line. That means H is the constant line. Okay. This is the inversion temperature. Inversion temperature. Okay. Just I am using different color so then you will be better understand. Left side of the inversion temperature, this curve has positive slope or negative slope. Hello?
Yes, it is positive.
It is positive slope. It is positive slope. The slope, you know that the dy by dx here, y is the dt or delta t by delta p. Delta p at, as this is the constant enthalpy line, so you have to write this h is constant. This red portion or left side of this point, this is positive slope, and the right side of the inversion temperature is the negative slope. Okay, this is the negative slope. That means delta t by delta p at constant enthalpy line. How this constant curve will have been drawn, I will explain a bit. Okay, this is the negative slope. Okay, what is this delta t by delta p? This is the Joule-Thomson coefficient. Okay, this is the Joule-Thomson coefficient. Joule-Thomson, THOM, Joule-Thomson coefficient. Am I right? Okay, this is the Joule-Thomson coefficient. So here the Joule-Thomson coefficient at the right side of the inversion temperature is the minus. This is the minus V, and here this is the positive V. One interesting thing, suppose because this is important. You should understand these things. What happen? Suppose, what is the main purpose of the throttling? What is the main purpose of the throttling? Reducing the pressure. Okay, reducing the pressure. Suppose this is point 0.1 pressure. This is suppose point 0.1. Suppose this is P1. This is P1. We are reducing the pressure from P1 to P2. P1 to P2. P1 to this is the suppose P2. What will happen? What is happening here? Suppose I am going from the throttling process is the pressure reducing process. So I am coming to the right to left portion, left to left directions. So I am reducing the pressure from P1 to P2. That is the throttling process. That is the throttling process. What is happening? The temperature is increasing or temperature is decreasing?
Increasing, temperature increasing.
Temperature is increasing. That means temperature T1 is lower than the T2. I mean temperature T2 is higher. Okay. Temperature is T2 is higher at which positions? At the positions where the mu is negative. That means delta T by delta P at constant enthalpy is minus V, negative. Slope is negative. Okay. So at the inversion point, what is happening at the inversion point? At the inversion, suppose at the inversion point, suppose let's say pressure is P3. Suppose I am reducing from the pressure P2 to P3. That okay. This is also throttling process. What is happen? The also the temperature will increasing. Okay. The T2 T3 is higher. T3 is higher. This is also in the zone of mu equals to minus V. Okay. But after reaching the inversion temperature, here is the T3 is the inversion temperature. Okay. T3 is the inversion temperature. Inversion. We are SI okay. Okay. This is the inversion temperature. I am writing here. T3 is the inversion temperature. Inversion temperature. T3 is the inversion temperature. So what is happening at the T inversion temperature? What is the slope? I mean, what is the mu or what is the dt by dp? What is the value of dp by dt at the inversion temperature? If the questions is come in your gate examinations or any other exam, this is very important. Sometimes these questions will ask in gate, graduate aptitude test in engineering. This is the main concept of the throttling process. What happened? Do you know? Where the slope is changes from negative to positive, the slope value will suppose this is one scale. Suppose this is negative, -1, -2, -3. This is suppose 1. This is suppose 2. This is 3. From the changing from the minus value to positive slope, intermediate, this is the 0. Am I right? This is 0. Is it clear? Am I clear? Hello? Hello? Okay. So at the inversion temperature, the Joule-Thomson coefficient is 0. Suppose we are further reducing the pressure from P3 to P4. P3 to P4. What what is happening? P3 to P4. Suppose this is condition P4 condition. Further reducing the pressure. Suppose P3 to P3 to P4. This is also throttling process as we are reducing the pressure. Okay. Here what happened? The temperature is start decreasing. T3 T3 will be higher than the T4. If we further reduce the pressure like P5, suppose pressure 5, this is the pressure 5 conditions, P4 to P4 to P5. This is also throttling process. Here the T4 temperature is higher than the T5 temperature. T5 temperature. Okay. So left hand side of the inversion temperature during the positive slope, the if we do throttling, then the temperature of the gas of hydrogen will reduce. If we can arrange or we can reduce the temperature up to 20 Kelvin, then the hydrogen gas will convert into liquid phase. Is it clear? This is all about the how hydrogen gas is converted from gaseous state to liquid state. Okay. So what is the inversion temperature? What is the inversion temperature? At inversion temperature, you know that this is the inversion temperature where the slope is 0 or Joule-Thomson's coefficient is 0. That means delta T by delta P at constant enthalpy it is 0. Okay. And only the below the inversion temperature, if you there are two conditions, it should be follow the positive slope and it should be below the inversion temperature, then only you can cool down the hydrogen gas and then only you can achieve 20 Kelvin temperature. Okay, then only you can make the hydrogen gas from the gas state to liquid state. I think it is clear. Okay. uh, this is the throttling temperature inversion temperature at different curve. When you will draw different isothalpic curve like the inversion point will come like this and it will make one inversion line like this. This is the inversion line. It will like this. It will like this. Okay. It will like this. Okay. So what is our main
So is it the parabolic curve?
this curve is parabolic curve. Okay, this curve actually will depend at which conditions you are plotting the first graph. Okay, according to the first graph, this first graph means that the suppose this is the h1, this is the h2 and this is the h3. Okay, and if you plot this H1, H2, H3, H4 at a different energy level, you will get one different inversion temperature. If you plot this, you will achieve these things. Okay. So what was what's the three step? Three step was the first is the compression step, second was the pre-cooling, next is the throttling process, and fourth one is the Joule Thomson coefficient should be positive. Okay, then only you can achieve the liquid hydrogen. Liquid hydrogen, this is important. Then only you can achieve the liquid hydrogen 20 Kelvin. Then only you can achieve the temperature 20 Kelvin. So major step is the mu should be positive value. Then if you decrease the pressure, P2 is the final pressure, and temperature should be temperature inversion temperature should be below the inversion temperature. Below the inversion temperature of the hydrogen should be below the inversion temperature. How the temperature will be reduced? I mean, how the temperature you can reduce from the below the inversion temperature? By using pre-cooling. This is the pre-cooling. So pre-cooling is a necessary step before the throttling step. Okay. So it is here written that the compressing step, chilling step means that the temperature is reducing step. It should be below the inversion temperature. Okay, below the inversion temperature. Then the expansion or throttling process. Throttling process also decrease the temperature. Throttling process also decrease the temperature when the Joule Thomson coefficient is positive, and throttling process increase the temperature. It is the another part. Throttling process increase the temperature when the temperature is not mu is negative V. Okay.
So in case of hydrogen, the when we do the throttling,
Yeah.
due to throttling, the temperature will reduce. Is that
Yes.
it?
Yes, exactly. Yeah. Throttling, during the throttling process, temperature is also reducing. During the chilling process, temperature is also reducing. But the main purpose of the chilling just to cool down the temperature below the inversion temperature. But the throttling process, in the throttling process, the main purpose of the throttling process just reduce the temperature, more reducing temperature just to attain 20 Kelvin temperature, because at 20 Kelvin temperature it will from liquid. Okay, liquid hydrogen, then only you can get the liquid hydrogen, because we know that the liquefaction of the hydrogen is the 20 Kelvin. Okay, this is the very simple things. That is the liquefaction fluid acts as a coolant. Okay, sometimes.
Sir, just one point, one
Yeah.
point. So in the we do before this throttling, we do the cooling.
Yeah,
So should you cool below the inversion, or this inversion temperature will be reached after the throttling?
suppose inversion temperature of hydrogen what, 200 Kelvin. That means a minus 70 or minus 68 degrees centigrade. That is the 200 Kelvin. Okay. So you have to chill, or you have to cool down the hydrogen below the 200 Kelvin. That means you can make 190. Okay. Then only you will go for the throttling process. Then only you can go for the throttling process. Okay. Depending on the throttling process, depending on the pressure, how much you have compressed, this throttling this throttling temperature will be decided. Okay. Then only you can achieve the 20 Kelvin. Okay. 20 Kelvin. Is it clear?
Yes, sir.
Yes. Uh, Next is the process in hydrogen liquefations. I think I have already discussed. First is the compression state. This is the cooling, and this is the expansion state. Okay. Okay. During the large scale hydrogen liquefations, during the large scale hydrogen liquefations, some scientists have uh, explained there's some cycle. There the important cycle you have to remember: simple Claude cycle, Kaptiza cycle, dual pressure Claude cycle, pre-cooled Linde-Hampson cycle, pre-cooled dual pressure Linde-Hampson cycle, helium pre-cooled Claude cycle, pre-cooled mixed refrigerant and cascade system. Okay. Next we'll discuss the simple Claude cycle. Uh, I think this is well known to you. I think you will know. You have already studied. This is the gaseous hydrogen is fed into the compressor. This compressor is intercooled compressor. This is heat exchanger. That means why here the intercooling is accommodated.
To reduce the work done to the compression system.
Good, to reduce the work done. Reduce the work done. Reduce the work done.
Or to achieve the isothermal
Exactly. And
efficiency.
for the, because we know that the work done for the iso, isothermal process, work done is less than the isentropic compression process. So this is the isothermal process, isothermal isothermal process, isothermal process. Otherwise, what will happen if we don't cool the compressor or cool the gas? What will happen if we compress the hydrogen? If we, in the first class, I told you that if we compress the hydrogen gas, what will happen? The be temperature will be
Increase.
high, increase. Okay, temperature increases. Yeah, temperature increases. So temperature, what is the effect of this high temperature? This temperature,
So volume of the gas will increase,
yeah,
and so ultimately we have to
explosions
reach
may
to
occur.
a
Explosion may
pressure.
occur.
So
Okay,
it will need to, I mean,
lead to
more
explosions.
work to be done to
Yeah,
the compressor.
yeah, yeah. So then intermediate cooling, then also one heat exchanger with intermediate cooling is accommodated here. Okay, then first consider, don't consider this one. Next I'm going to, this is the compression step, this is the cooling step: first cooling, second cooling, and third cooling by using the heat exchanger. Okay, then we are coming to the throttling valve. Okay, this throttling valve is doing, or a throttling valve is also reducing the temperature of the hydrogen, and finally we are getting the liquid hydrogen. This is the liquid hydrogen. This is the liquid hydrogen. Some gaseous hydrogen will also be there. Okay, some gaseous hydrogen will also be there. This gaseous hydrogen we don't, this is not desirable conditions, so this gaseous hydrogen will fade back to the initial, for initial compressions. Okay, during this gaseous hydrogen temperature is very less, so this temperature is less, so by using this heat we can cool the, or we can cool this hydrogen. Okay, we can transfer the heat from here to here. Okay, but in between, what is the expander? Expander is also adding here. This is also added here for reducing the temperature. Okay, for reducing the temperature, this is also used just for reducing the temperature. Okay, just 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 we are using the expander because the temperature will be lower during, temperature will be lower at the inlet of the compressor, such that the temperature will not high at the compressor. Okay, such that the work done will be less and the process will be totally isothermalic process. Okay, This is the simple Claude cycle. This is the simple Claude cycle. I am not going into details here. This is also simple. You can study from your
So
own side.
in Claude cycle, there will be three-stage cooling after the
Yeah,
compressor,
there is three
or
stage
or
cooling.
the or the number of stage will vary.
Yeah, you can increase the cooling process, or you can accommodate more number of the heat exchanger. Okay, you can accommodate 4, 5, 6 heat exchanger in place of 3 heat exchanger. It is not like that. Okay, you can accommodate more number of the heat exchanger such that you can achieve lower temperature before throttling. Okay, this is the pre-cooled Linde-Hampson cycle. Okay, what is happening here? This is the process intermediate cooling compression process. Okay, this is the heat exchanger here accommodate. This heat exchanger, the hydrogen gas is cooled by using the secondary cycle like liquid nitrogen cooling cycle. This liquid nitrogen cooling cycle will absorb some heat such that the gas of the hydrogen temperature will be reduced, and further it will go into the throttling device. This is the throttling device symbol, and it will uh, isotropic expansions will occur, and this liquid hydrogen, you will get the liquid hydrogen. Okay, again some gas is there. This gas is further compressed, and this liquid you can store in the cylinder, liquid cylinder, hydrogen store cylinder. Okay, this is the pre-cooled Linde-Hampson cycle. He has introduced one second cycle, secondary cycle, secondary cycle, that is the liquid nitrogen cooling cycle. Okay, by using the secondary liquid nitrogen cooling cycle, that means just to exchanging heat, nothing like that, nothing like so much difficult. Okay, this is the same things actually. What is the specific? As he has introduced on secondary cooling cycle, the efficiency, he has got very high efficiency. What the efficiency? First, the Claude cycle. What is the Claude cycle? Claude cycle requires 22.1 kilowatt per kg of hydrogen. Okay, but by using the pre-cooled Linde-Hampson cycle, the energy required is much lower, that is the 16.24 kilowatt hour. Okay, it can be further reduced by using the dual compressor, or dual compressor means that the here the one stage compressor. You can reduce the work done, I mean you can reduce the work done, I mean reducing the power consumptions to make the gaseous hydrogen to liquid hydrogen. Okay, finally the latest value whatever he has reported, that is a 6.66 kilowatt per kg of hydrogen. This is the cooling process. This is, it is a number of the step is associated here. Whatever you were asking, that the this is the it is a expansion of the Claude cycle. The Colin, scientist Colin has discovered this process, or scientist Colin has made this cycle. Okay, that's why this cycle is called Colin cycle. For each and one, for every heat exchanger, he has associated, he has accommodated one expander. Okay, in between one expander. Okay, so just to reduce the, just to increase the efficiency, or just to reduce the energy consumptions, this is called cooling process. Okay, this is a very simple thing, cascade system. You know that the, this is the complex, this is the multiple multiple stages associated for reducing the temperature. Okay, independent of the cycle, pre-cooled other refrigerant cycle approaches closer to ideal reversible liquefacions for a wide temperature required to improve the liquid yield and efficiency. What happening, all the process is doing here just to reduce the temperature, such that before the throttling device, the temperature will be very less. Okay, such that the efficiency will be high. All the things is done here just to reduce the temperature or increasing the efficiency. Summary you can study. I'm not going into details. Challenges, you know that the requirement of the extremely low temperature. What is the hydrogen storage challenges? You know that the temperature is 20 Kelvin. This is the very very lower temperature. You have to maintain this lower temperature, otherwise hydrogen gas, hydrogen liquid will be converted into gaseous phase, and this gaseous phase will be raised in pressure, and the pressure may catastrophically fail the hydrogen storage cylinder. The capex is high capex store because you have to reduce so much temperature. That's why associated capex is very very high. All the accessories and connecting component must be lower temperature. So you have to added some insulations. So the cost of the insulations for making or for reducing the heat loss from the cylinder as well as from the different pipe, you have to make you have to use high quality insulations. So the cost of the insulations will be very high, so capex also will be very high. And the boil off is a consideration things, that the boil off, you know that the it is the making of the liquid state to gaseous state. What is the boil off? Acha, just to reduce the boil off, you have to assure that there is a good quality of the thermal insulations. Ortho to para conversions, there is very less ortho to para conversions, otherwise the inside energy will be generated or inside energy will be released, and the temperature will be rise up, and the gas liquid hydrogen you cannot make it liquid. The liquid hydrogen will convert into gaseous hydrogen. And the tank shape, dimension and shape and size will also be one crucial part to reduce the boil off. Because suppose if you design one spherical system or spherical tank, what will happen? The surface area will be lower. That means that the heat losses from the lower surface area will be less. If we reduce the same volume, if we design the same volume of a cylindrical tank, this the cylindrical tank as surface area, outside surface area is quite higher than the spherical system. So the as the surface area is very very high, so the probability of the heat loss will be high. So the shape is one important considerations to reduce the boil up. Pressure relief valve, you know that all the things you can understand. Already I have discussed ortho to para conversions, heat leakage. You have to minimize the heat losses. Thermal insulation should be satisfied. This is the thermal stratifications. This is the liquid and vapor interface. This liquid and vapor interface will also suppose this is the liquid and vapor interface. This is liquid and vapor interface will increase the pressure, and so we have to, so you do not allow the liquid to make the vapor conditions. Okay, sloshing means sometimes suppose sloshing means you have noticed, have you noticed in the NH or national highway that the tank design is like that, like this. Suppose tank design is like this in the truck. The tank design is like this. This is the suppose conveyor, some vehicle. This is some vehicle truck. This is some vehicle truck. This is the truck. Tank design like this. Why this curve is designed? Why this tank is curve type or curvy type?
To
Do you
reduce
know?
the sloshing, basically.
Yeah, to reduce the sloshing. To reduce the sloshing. Because if the tank dimensions or tank design is like this, simple tank design like this, so during the movement of the truck or bus, what happen? This liquid nitrogen or liquid gases will be collide each other. This during the collide, the kinetic energy will be high and high heat will be generated. This high heat may boil off the hydrogen liquid or liquid hydrogen. Okay, so this type of arrangement, this type of tank is designed for carrying the liquid fuel. Flashing, I mean that the transfer of liquid. Transfer of liquids mean the during the refueling station, during the fueling or refueling part. Okay, the some kinetic energy will be high, and that this kinetic energy may the energy will be high, and this energy will added to the liquid. This liquid may boil off. Way to reduce the boil off, this is the simple considerations for reducing the boil off. Okay, you can study requirement of the material for the liquid hydrogen. You have, this is a very simple part. I am not going into details. This is also very simple. This is also theoretical part, you can understand. Okay, this is the design part. Okay, this is one pictorial view, that is a global status. This is NASA is using this spherical hydrogen storage system because they uses liquid propellant. Okay, liquid hydrogen propellant. I told you in the first class, like rocket propulsion, NASA uses the liquid hydrogen. Okay, liquid hydrogen, they uses liquid hydrogen for storing this liquid hydrogen. They are using the spherical design, because why they have used design such a spherical shape, because heat loss will be minimum, because the surface area of the tank is lower. Okay, this is summary, you can study. Some of the physical storage systems like compressed state storage system, liquid state storage systems, cryo compressed, that means cryo means that the lower temperature storing systems. Solid hydrogen, you can also store solid hydrogen, that means below 14 Kelvin. Liquid hydrogen at 20 Kelvin. Okay, chemical storage like sorption material, metal hydride, complex hydride, and chemicals hydride. Okay, this is the simple things. Okay, this is important requirement for material or hydrogen storage systems. Okay, suppose you are storing hydrogen. Suppose this is physical storage. Suppose you have one material like MOF COF. The hydrogen is storing inside the MOF pore. Okay, so how the hydrogen is adhering to the MOF pores, that is the adsorption process. There's the difference between the adsorption and adsorptions. Okay, first one is the adsorptions, ADSORPTIO, adsorptions. That means it is the surface phenomena. Whatever the pore in the surface, suppose material you have one material like this. This is pore. This is 4. This is 4. Okay. In this 4, the liquid hydrogen or gas hydrogen will store. Okay. If the porosity of a material is very high, okay, some material have the porosity of the very high. It can store very larger quantity of the hydrogen. So hydrogen also can be stored in the material like MOF, COF, those material which have higher porosity. So during the absorption process, during the storing process, you have to release the hydrogen also. When you will heat this material, this hydrogen will be released. You will get the again hydrogen and you can use this hydrogen. So the reversibility will be should be there, because it is not like that it is chemically already chemically bond. You cannot, you are giving some heat, you are not releasing the hydrogen. So reversibility should be easy reversibility. Okay, it should be reversible process. Fast kinetic, I means during the absorption process, during the absorption process, okay, it will absorb easily and it will release the hydrogen also easily during the desorption process. Okay, the high stability, okay, long cycle life, and low cost and high safety. This is the adsorption process. Adsorption is the surface phenomena. The hydrogen molecule will adsorb to the surface. It will not going into the deep or bulk positions, but absorption, it will absorb, it is absorbing. That means the hydrogen gas is diffusing in the bulk of the material. Okay, so it is the surface phenomena. So it is the surface phenomena, it is the surface phenomena, it is a bulk phenomena, it is the bulk phenomena, the bulk phenomena. Okay, this is not chemically bonded. Actually, this is not chemically bonded. What is the chemically bonded storing system? Do you remember what is the chemically bonded hydrogen storage systems? In the form of metal hydride. When the hydrogen is stored as metal hydride, this is the chemically interacting, but here is the physically interacting. This is the physical process. This is the physical process. But metal hydride, but metal hydride, but metal hydride, this is the chemically process. So which one is the good? This process is good. Physical process or metal hydride hydrogen storage is good? So obviously, this physical process is good because the reversibility is very high for the absorption or adsorption process. This is some isotherm. This is a type 1 isotherm. Uh, this is the pressure ratio. P by P0. This is the absorption amount or adsorption amount quantity. Okay. This is the type 1 carb. Type 1 carb. Actually, there are different carb. Okay. There are different layer of absorptions, monolayer absorptions, multilayer absorptions. Okay. By using this carb or by drawing this carb, by drawing the isotherm, you will get whether the hydrogen is storing in the monolayer form or multilayer form. Okay, at very lower pressure, what is happening at very lower pressure? Drastic amount or very large amount of the hydrogen is storing, but as the higher pressure, what is happening at the higher pressure? Very asymptotically, it is forming plateau. Okay, it is not like that the hydrogen is absorbing so faster way. Okay, in the initial conditions, as there is a less amount of the hydrogen or is a lower pressure, the hydrogen can be stored larger amount, but next at the higher pressure, hydrogen will store at the very lower amount. This is the next is the type 2 process. Type 2 process is the type 2 process at the lower pressure. This is the microporous filled gases. Then the plateau, it is not forming proper plateau. Okay, plateau represents what is the monolayer. Okay, up to this monolayer, and at a higher pressure the multilayer continues and the condensation due to the capillary forces. Okay, if you want to go to, if you want to details absorption isotherm, okay, you can study it from your side. Okay, this is the interesting part. Actually, the details study, if I want to discuss, it will take a larger time. Okay, there are five types of isotherm, just you remember. Okay, and in the type 4, type 3 multi-layer absorptions, okay, you just remember the multi-layer absorptions, there is no monolayer. Okay, but here in the type 2, first is the monolayer absorptions, next is the multi-layer absorptions. Okay, but the type 3, there is the only monolayer absorption, this is the only whole monolayer absorptions. Okay, and the type 4 is the totally capillary condensation occur. There is a monolayer followed by the multilayer. First thing is the monolayer, then is the multilayer. Okay, type 5 is the similar to the type 4. Okay, this is some theoretical part you can go through. Okay, this value you can go through the from the table, or you can remember the table. Okay, this is some carbon material is used for absorbing the hydrogen. This is there are different carbon allotrope like graphite, carbon nano, carbon nanohorns, carbon tubes, graphene dots, diamond. Okay, onion like C. There are the different allotropes. They are all used for the hydrogen storage systems or hydrogen storage material. Activated carbon, I have already discussed that the activated carbon has a very high, it is a very high porous material. Okay, carbon nanotube also porous material, or is a with the largest with the high amount of the active sites, or carbon nanotube, carbon nanofiber are also used for the storing the hydrogen. This is the adsorption process is the surface phenomena. Okay, because for the good adsorbent, for a good adsorbent, what is the main criteria for a good adsorbent? For a good adsorbent,
It is reversibility. Then it should mm, reversibility.
reversibility.
Then good
Next,
kinetic.
huh. First one is the pore. So surface area. Surface area should be very high, or pore number of pore is should be very high. It should be very porous, such that if the material is very high porous, then only hydrogen will be trapped into the porosity. So high porous. The porosity should be high. Porosity should be high. Okay. The porosity should be high. Surface area should be high. Surface area also should be high. Specific surface area. So for the designing, for taking you one material, suppose activated charcoal. I have given you one example that why the activated charcoal is used for facial, because activated charcoal has very high number of the pore. Pore size is very high. The all the dirt particle will adhere to the pore of the activated charcoal. Okay, similar that the hydrogen will be stored into the pore of the activated charcoal. So reversibility should be high, surface area should be high, porosity should be high. There are different material. MOF is also one of the important material for storing the, for absorbing the hydrogen or storing the hydrogen. You can go through the whatever the given data is here, how the hydrogen is stored, for the first. Okay. This is the mechanism of the hydrogen storing. This is the mechanism. Suppose you have one, you have one material, porous material, or any kind of material, any kind of material. Suppose this is hydrogen. Hydrogen is on the top of the material. So, first hydrogen, what will happen? Physiosorption, adsorption. Physiosorption means that the acha, how it will attracted to the this metal. Do you know the what the force is playing here? The force is playing here the weak van der Waals force. Due to the weak van der Waals force, this is attracting to the metal surface or any kind of material. Okay, and this when this is attracting, these molecules will come near to the surface of the material. This is called the physiosorptions adsorptions. Okay, next is the absorptions. When the hydrogen molecules come to the this surface, this will go inside the bulk. So it is called the absorptions, or this is the bulk phenomena. Or this may bond inside the material. This may form the covalent bond for the case of the metal hydride. Okay. Okay. Some comparisons of the different storage method. This is okay. You can understand that for the liquid case, it will require this much of higher amount of the cylinder. When we use the this material, LaNi5H6 metal hydride complex form, it will require the volume will be reduced than this the liquid hydrogen tank. So okay, when we will use these things, this metal hydride things, then the size of the absorbent will be reduced. So volumetric specific volumetric calculation, volumetric value will be lower. Okay, volumetric size of the hydrogen tank will be lower. Okay, volumetric energy density actually. Volumetric capacity, this graph has plot like this. There are different material. Actually, this material in the metal hydride or complex metal hydride, this is the complex metal hydride. All the complex metal hydride, complex metal hydride. This is the complex metal hydride. This is the important sum. This is which which material will form the ionic hydride, covalent polymer hydride, metallic hydride, and metastable hydride. Actually, this is the ionic hydride. This form the ionic hydride. Lithium, barium, sodium, magnesium, potassium, calcium, rubium, strontium. Okay, and the covalent bond. This color is forming the covalent bond with the hydrogen. This is a covalent bond, because we know that the covalent bond carbon and hydrogen is form the covalent bond. You know that the covalent bond carbon hydrogen. Okay, methane CH2. This is the covalent bond. Okay, and this is the covalent polymeric hydride. This covalent polymeric hydride. This the covalent polymeric hydride. This will form also covalent bond. Metal hydride. Metal hydride. These are the metal hydride. All the metal hydride. Lanthanum, cesium, okay, titanium, sorry, Ta, Nv, vanadium, titanium also, Okay, these are the all the these will react to the hydrogen. This will from the metal hydride. Simple things. This will metal hydride. This will form metal hydride. Okay, this is the ionic hydride. This is the ionic hydride means the ionic conditions. Okay, like H plus, Na plus. Okay, this will form, and this is the covalent bond. You know that the methane like this. All this you can go through. Class of the hydride: ionic hydride, covalent hydride, and metallic hydride. What are the specifications of this ionic hydride? Hydrogen is negatively charged in the ionic hydride, and this is the hydride form. This is called hydride. H minus. This is called hydride. Okay. Covalent bond. Covalent bond formed with a non-metallic compound and weak van der Waals forces. Okay. This is the NH3. Ammonia. Ammonia is the covalent formations. Okay, when the hydrogen is stored in the ammonia formations, so this means this is not the metal hydride complex. This is the covalent hydride. Okay, or metal hydride, vanadium hydride, titanium hydride, or this is the complex titanium plus iron hydride. Okay. Mechanism. What is the mechanism? Mechanism already you know that A is the hydrogen molecules approaches to the metal surface. Already I discussed. First approaches to the metal surface, then the interactions of the hydrogen molecules by the van der Waals forces. It is coming to the closer to the metal surface, coming closer. Then it is then the chemisorb. This is the chemisorb. Chemisorb means that this is the dissociations of the hydrogen molecule. It will form the atom. This is in the molecular form. Molecular form. Chemism is the process of dissociations of the hydrogen into atom, two atom, hydrogen atom, H atom. Then this hydrogen atom will go inside the metal or diffuse. Then the it will diffuse inside the metal. Diffuse means that it will move from one place to another place. This is called the diffusion. So first is the approach of the hydrogen molecules to the metal surface. Then the some van der Waals force will be generated. Okay. Then the chemisorb means that the two atom will generated. Then it will diffuse into the metal hydrogen. This is the absorptions. This is the desorptions. When the absorptions will occur, some heat will produce. You have to remove this heat. Otherwise, the system will not efficiency will be low, or the absorption process will be lower. And the desorption process, during the desorption process, you have to give some heat. Then only the physical attractions or physical bonding between the metal and hydrogen, you have to break this physical bond or a chemical bond. Then only you can get then only the hydrogen will come out. Okay, this is the process. So absorption process is the exothermic process and desorption process is the endothermic process. Okay. uh, this is actually some I will explain it actually. What happened? Material in alpha phase and material in beta phase and material in gamma phase. You know that this stage, material, this different stage, alpha, beta, and gamma. At lower temperature, iron is at alpha state. At higher temperature, alpha generally at gamma or beta stage. Okay. So at gamma phase, the hydrogen, larger amount of the hydrogen will go inside the metal or interstitial of the metal. And when the hydrogen will go inside the metal, what will happen? It will cause some defect, or it will generate some stress inside the, or it will distort the dimensions, or means the dimension will increase. Initial dimensions, from the initial dimensions it will increase because some hydrogen is absorbed inside the material or metal, and it will distort the material, or it will distort the, what is called, I can say that the grain, or it will distort the grain boundary. Grain, if I want to give some example like this, every material actually is made of, you have seen the pomegranate. Okay, what is inside the pomegranate? The outsider surface is very smooth, is a covered pomegranate. Okay, and inside the pomegranate there are the number of the small seeds. It is covered by the some grain, red portion, that is important for our food. Okay, this is the grain boundary inside the, this is the grain and inside the seeds. This is same thing is inside the metal state. If the hydrogen is entered or entrapped into the grain, it will expand, and some distortions will happen, and grain boundary will, the cracking will be there in the grain boundary. Okay, and the stress will be generated inside the metal, and due to the this stress the hydrogen embrittlement will occur, and the sudden failure will occur. This is the main concept actually. This is the process, you know. Okay, whatever I will discuss here, the for a brief, isotherm. Okay, isotherm. Isotherm means that the, this is the hydrogen concentrations, hydrogen divided by metal, hydrogen to the metal, hydrogen to the metal. This is the hydrogen concentrations during the initial, for the low pressure, for the low hydrogen pressure. What is happening? For the low hydrogen pressure, there will be only alpha phase. There will be only alpha phase. Next, it is the combinations of the alpha plus beta phase. Next is the only beta phase. You just remember these things. This is the alpha, this is the 1, this is the 2, and this is the 3. And the formula, the Gibbs free rule, freedom, or the F equals to C compositions plus 2 minus P. This is the phase, and this is the compositions. Here the compositions is the, what is the two compositions? Here the hydrogen and metal. They are the two compositions. Okay, so C is 2. C is 2. Hydrogen and metal. It is, hydrogen is absorbing inside the metal. So there are two phases. So, sorry, there are two compositions, metal and hydrogen. So C is always 2 and plus 2 for the alpha, for the alpha state, or for the alpha hydrogen. You can calculate the degrees of freedom, like C equals to 2 for every cases, and P here is the 2, that is the alpha, and what is the other? Alpha and Anyone of you? Hydride, alpha and metal hydride. Alpha or hydride, actually. Metal hydride, nahi, hydride. Hydride means the minus, H minus. Okay. Or alpha hydrogen means this is not hydride state. This is normal hydrogen, but in the alpha state hydrogen. Is it clear? If you have any confusion, you can ask me. So the degrees of the freedom will be here. The for the case first case it is 2, second case it is the 1, and third case it is the 2. Because in the second case the phase is actually, what is the different phases? Alpha, beta, and third one is the phase is the phase is the alpha, beta, and the hydride, H minus. Okay, hydride is present in the all cases. Okay, this is also hydride, but in the second stage alpha, beta, and hydride. And compositions, you just remember these things. And composition, C is the compositions is the metal and hydrogen. Me, metal plus hydrogen. This is the composition, metal and hydrogen. And phase is the alpha, beta, and hydride phase. Okay, of hydrogen. Okay, so first is the alpha plus hydride phase, second is the alpha plus beta plus hydride phase, H minus, and here is the beta plus hydride phase. Just remember. Okay, next I am coming for discussions of the some of the MCQs. Okay, so coming to the first questions. First questions, it is like remember type questions. How much amount of hydrogen, how much amount of energy is released for conversions of normal hydrogen to equilibrium hydrogen?
It is 5 to 7.
It is 5 to 7. Uh, can you explain the things? Normal hydrogen to equilibrium hydrogen means?
Yeah, it means normal hydrogens means 75% ortho and 25% para.
Exactly.
So if we convert this ortho to para, 75% ortho to 100% para. So then these 5 to 7 kilojoule per kg will be released.
Okay. So the release amount will be 527 for 100% para or 99% para. Is it okay? The
Yes, yes.
energy will generated 527 kilojoule per kg. Okay.
And if it is liquid stage, I think complete conversion. So it says 703 kilojoule per kg.
Huh. Suppose 100% ortho. Suppose there is 100% ortho. 100% ortho. The energy will release 7
703.
or 620. Just you will go 703. 703 kilojoule per kg. You just remember that means 100% ortho to 100% para. It is clear? Two things. I
Yes,
think
yes.
this is clear. In which of the following cycle reciprocating expansion engine is used? Reciprocating expansion engine. In the Claude cycle, simple Claude cycle, there was one simple expander device. You remember expander device. Dual pressure Claude cycle, there was expander device, but the pressure was dual. I mean that the double stage
Yes,
compressor,
double expander was there.
double expander, or double compression stage, two stage compression, two stage compression. It is not writing properly. Okay. Captija process. The answer will be Captija process. Here the reciprocating compressor engine, it uses reciprocating compressor engine. Why this Captija process uses reciprocating compressor engine? Because for the industrial applications, or for the higher, for the larger scale applications, for large scale applications, this process is used. Because reciprocating compressor, reciprocating expansion, that the reciprocating has a higher flow rate. Okay, already you studied. So larger case, you have to use the Captija process by using reciprocating expansion engine. Larger, where the larger requirement of the liquid hydrogen, liquefaction of the hydrogen is required, we will go for the Captija process. Okay, larger liquid hydrogen production. Liquid hydrogen.
But we discussed about the Linde-Hampson cycle. So
Ah,
there also we use
Linde-Hampson cycle is different from the Claude cycle, na? Linde-Hampson
yes,
cycle
there
was,
we are using another, I mean, nitrogen
yeah,
secondary
yeah,
cycle.
secondary
So
cycle.
there, have we used the expander or compressor? I think compressor.
Uh, Compressor is for all the cases. Compressor is for the all the cases. I have to go to the previous slide
No,
actually.
that I said that for the secondary cycle, in the
For the
secondary
secondary,
cycle where nitrogen was used, in that
yeah.
also we used one compressor, but that was for I
Okay,
think
okay.
compression.
That was for the secondary cycle. Will not, that is for the liquid nitrogen cycle. For the liquid nitrogen cycle, that was for the secondary cycle. Secondary cycle, that was the liquid nitrogen. We are not correlating this secondary cycle. Here we are discussing for the first cycle. Okay, whatever the liquid secondary cycle uses, that we don't care. Okay, but we are using for the reciprocating expander device into the main cycle. Main cycle. Okay, understand?
Yes, yes.
Yeah. Next question is the question number 3. Which is the chemical method of hydrogen storage? It is very simple questions. You can answer that the metal hydride is the chemical process because it is in hydrate state, H minus, and it will make some covalent with the liquid metal. Suppose titanium or vanadium. Suppose titanium, if the titanium is metal is used to react with the hydrogen, and it will form metal hydride. Suppose TiH, TiH. Okay, metal hydride. Compressed hydrogen storage. You know that compressed hydrogen storage. It is a mechanical.
Yes, yes, it is clear. I mean, other three
Other
process,
is
those are
very
not
good. Okay.
chemically composed.
Question number 4. Which assumptions is taken in BT adsorption isotherm process. Adsorption means that the physical phenomena. It is a physical phenomena. It is a surface phenomena. It is not bulk phenomena. It is a physical phenomena. Oh, sorry. I have to rub it. I don't know how it will happen. Okay. This is the adsorption.
Yes, I know. In absorption means the physical phenomena like the silica gel we use. I mean, in the new shoes when we purchase, those are the gels, and
Exactly.
the
Exactly.
absorption like the sponge
No,
we
no.
use. So
Silica.
where
No, no. Silica.
the liquid enter into the structure.
Ha. Silica gel actually it is a absorption process. Silica is a absorption. Silica will absorb the water vapor from your laptop bag. Okay, silica is a absorb, which will absorb the water. Adsorption means that there are some pore, only the hydrogen will adhere to the pore. It will not go into the bulk. But exactly what happened? But suppose you have one material, there's a lots of pore. This is the pore. This is the pore. This is the pore. Suppose activated carbon. If you see this activated carbon in the micro under the microscopic, there will see the number of the pore in the activated carbon. So hydrogen will entrap into the pore, but into the absorption process. Suppose absorption process, there is no pore. In the absorption process, there is no pore, but due to its own physical phenomena or chemical phenomena, it will absorb the water. Okay. So gas molecule are physically adsorbed in the monolayer. Gas molecule are chemically absorbed in the infinite layer and layer being interacting each other. Gas molecule are physically adsorbed. This is the adsorption process. Obviously it will be adsorbed. Obviously it will be adsorbed in infinite layer, and layer is being non-interacting. But when the in the layer when the in the layer, it will not react. Okay, it will just uh, adhere to the surface due to the adherence property, or maybe you can say that the some smaller interactions like van der Waals interactions. So our answer will be, what will be answer?
I think answer will be C.
C, because it is a physical process. Okay, it is adsorbing, not absorbing. Absorb, water will be absorbed, whole water will be absorbed. Okay, and in fact non-interacting, because it is not chemical process, so non-interacting. Okay.
Yes, my confusion was whether it will be infinite layer or the monolayer. So I think it is the infinite layer so that it can absorb more and more
Huh.
hydrogen.
Huh. Actually, there is a infinite layer, monolayer, multi-layer. It may happen. Monolayer, infinite. There is infinite layer. Monolayer means that the single layer. Suppose how the monolayer will happen. Just I have to have the example. Suppose you have one material like this. Suppose this is one pore. I have drawn this pore size very bigger dimensions. Don't confuse. This is pore. Pore means very smaller diameter, like a capillary pore. Okay, this is suppose pore. Monolayer means that the hydrogen will be absorbed in this way. The hydrogen molecules will be absorbed in this way. This is a monolayer. When the hydrogen gas will be absorbed uh, on the monolayer, again this is a multi-layer. Okay, this is absorbing due to the which attractions? Van der Waals attractions. Okay, you can study the Van der Waals attractions. This is
Okay,
very
okay, okay.
interesting thing. Actually, Van der Waals attraction depends on the radius of the two molecules it will attract, and all the things will come. A zeolite. Question number 5. Zeolite are classified on the basis of which ratio? Silica, alumina, silica, oxygen, silica, sodium, alumina, or silica, alumina. Which one will be correct?
Zeolite are classified on the basis of which ratio?
Uh, I
Uh,
mean, it is a combinations of the
Combination.
silica and alumina, not
Alumina.
aluminium.
Yes,
Alumina.
yes, alumina.
Okay. Question number 6. TIFE can be classified into which category of hydride? TIFE?
PIFE, metal hydride,
Huh.
complex hydride.
Uh, no, complex hydride, it should be, it is metal. It is actually complex metal hydride. It is complex metal hydride.
Okay.
Complex metal hydride. Okay. Question number C. What is the value of degrees of freedom in alpha plus beta region of the PCT isotherm? It is a very simple formula.
Yes, alpha plus beta
The
is
formula
a
is C plus 2
2 minus P.
minus P. For the case of the alpha plus beta region,
Hmm.
here for the metal hydride, the compositions is the metal
And
composition is the
hydrogen.
um, no metal and hydrogen. Na?
Metal and
Composition is the
hydrogen.
metal. Composition means the which material is composed for making the things. Metal and hydrogen.
Hmm.
Hydrogen gas. This is the metal and hydrogen gas. Hydrogen gas. This is the composition. Suppose okay. Suppose this is the metal hydride and hydrogen is absorbed or chemically reacted here. This is the hydrogen. The two composition. This is the metal. This is the
Hmm.
metal. This is the metal.
And another is
So
hydrogen.
our C value will be
Two.
2, and P value phase.
Phase is 2.
What are the different phases here? Here the alpha plus beta phase of hydrogen,
Hmm.
alpha and beta phase of hydrogen, and hydride phase of hydrogen. Hydride phase of hydrogen means the minus. So
Hmm.
there are total 3 phases. So P is our 3. So
P is
by
3. Okay.
so F will be calculated here. 2 plus
1.
2 minus 3, it will come 1.
Okay.
Which is meant by boil off losses of hydrogen? It is very simple, you have to answer. Evaporations
Yeah.
of hydrogen due to conversion of ortho to para hydrogen by means of reducing temperature. Evaporation of
No.
hydrogen, obviously evaporation of hydrogen due to the conversions of para to ortho. No, ortho to para.
No, it will be ortho to para.
So it is cancel out. Diffusion of the hydrogen atom into the metal lattice. Diffusion of the hydrogen atom, obviously during the absorption process there are the hydrogen will be diffused. Hydrogen will be during the absorption process, hydrogen will diffuse inside the metal,
Hmm.
and this is not the boil off.
Boil
Okay,
of, yes.
boil up means that the liquid hydrogen will convert into the gaseous hydrogen. Okay, so C option is
So it is,
also our cancel, and D
yes.
option is the condensations of the hydrogen due to the conversions of the para to ortho hydrogen by means of reducing temperature. This is
No.
also no. So
It will
our
be
option,
first one. Yeah.
so our clear
Evaporation.
option is the first one. Question number 9. Arrange the various phenomena involved in hydrogen absorption process in chronological order. This is the absorption process. Absorption process. Okay, you just this is the absorption process.
So arrange the various phenomena involved in hydrogen absorption process. Okay.
What is
Okay.
the what is the absorption process? Absorption process is the bulk phenomena.
Yes.
BULK, bulk phenomena.
So dissociation will, I mean, the atom formation will happen. Then with the van der Waal attraction, it will go inside.
Huh.
Okay.
So,
Penetration into the metal
so
surface. or
Suppose
diffusion. Okay.
suppose this is your metal. Suppose this is your metal. So absorption means that the some hydrogen will be go inside the metal.
Yes.
So just I am drawing the hydrogen atom. Suppose this is the hydrogen. Number of the hydrogen. Number of the hydrogen is here. Number of the
Mm.
hydrogen is here. So finally what will happen? Finally hydrogen will go inside the metal.
Inside the metal. Yes.
This is the metal. This is the metal. So what is the step involved? So first step will be
First
what
it
is the
will
first?
be growth, nucleation and growth.
Mm, first step will be nucleation and growth. No.
O- Okay, so it will divide in atom. So
First thing will hydrogen will come. First hydrogen will come. So first step will hydrogen will come closer
okay,
to the closer to the closer ClO ACr closer to the metal.
so it is
To the
called physiosuction. No.
MET. This is called closer to the metal due to the vulnerable interactions. So you have not remember or you should not remember the term. What is the physical thing is happening? You just remember. This is the vulnerable interactions. VNDR. Vulnerable interactions. Then I am not going into the chemical terms. Then is the splitting of hydrogen atom. Then is the splitting or dissociations. This
Mm.
is technical term is the dissociations. This is the dissociation. Dissociation. Next, pin number is the third number is the after dissociations it will go inside penetrations. Next is the penetrations. Next is the penetrations. Fourth one is the penetrations mean inside the metal. Next one is
Yes.
the diffusion. Inside the metal it will diffuse. Diffuse means the randomly it will move. Then is the diffusion.
Okay. Okay. Penetration, then diffusion. Mm.
Then diffusion. And nucleation growth is the due to the diffusion the nucleation growth will occur.
Acha, growth, right? Growth.
Then the growth will occur. Growth means just I am growth means the dimensions of the metal shape is distorted because the dimension will be larger as the hydrogen is inside the it is as hydrogen is moving inside the or diffusing inside the metal. So obviously the some stresses will generated and the size of the metal hydride will be larger. So nucleation growth will occur. Okay.
Yes.
So what is the our option will be correct?
Nucleation and growth, then physiosuction.
So what are the step?
Physiosuction
First
and
step is
diffusion.
the this one, second, third, fourth, fifth. So what will be the our answer? The first step will be this will be the last step. This is the last. This is the last
No,
step.
no, this is last before last.
No, nucleation growth is last. Fifth number is the
Okay.
nucleation. Fifth. This
No,
is the fifth.
there is six terms, six phenomenons.
Okay, okay. There is six phenomena, but just I am considering that this is the last.
Okay.
Okay, okay.
So nucleation and growth will be last.
This will be last option. So one will be our last. So one
Okay.
will be our last. There
So
are two
B
one.
or D. B
B
D.
or D. Okay.
So
Before last, what is happening? Before last, it is diffusion process.
Diffusion, yes. The five.
Diffusion process, this is the 5.
Yes,
So,
both are same.
so this option will be correct. Okay.
No, both are same. Both are same.
Acha, both are same. Okay.
Yes.
So this one is a diffusion process.
Then
Next,
before
then
that
the
penetration. Penetration. Okay.
the,
Penetration will come. So it is four. So it option will be D actually.
ah
D.
uh,
Penetration.
penetrations 6 is the
Yes. Third from last is penetration. So that is D.
no. Huh. Fourth one after penetrations actually the second formation. So acha, one step is actually I missed that the formation of the hydrate phase. Actually, total process is the hydrate phase, but
Mm.
after penetration,
Mm.
after penetrations, there will be after penetration there will be diffusion and the hydrate phase. Hydrate formations will occur actually.
Okay, okay, okay. So
Okay.
three. So
So
then, yeah.
actually, our option is B. Actually, here
Option is
as
B.
the option is here, the formations of the hydrate phase. So
Mm.
it will come in between.
Okay, okay,
So
okay.
our option is the B. So
Okay.
first option is the six.
Mm.
Six is the our fuse options. Okay, this is the one. This is one. Okay, third one is the second fusion after chemisoptions. That means that the dissociations. This is the two process. This is the fourth one is the this is the third process after chemisoption. It is the penetrations. After penetrations, third, fourth after penetrations. Sorry, third. Huh. After penetration,
Four
second
is
is the
penetration. Okay.
this is the fourth. After penetrations, that means after penetrations, it will form metal hydride. This will be
Mm.
metal hydride. I have missed one form, metal
Yes, yes.
hydride. That's why it is confusing. Hydride. Okay. Then metal hydride, like this process. But you have to remember this step. Okay.
Mm. Yes, yes.
Option 10, question 10. What is the specific energy consumptions in kilowatt per kg of hydrogen liquefaction in ideal Linde-Hampson cycle and dual Claude cycle respectively? Okay. What is
Okay,
the
so
Linde-Hampson cycle and dual pressure Claude cycle? You just remember in which cases the specific energy consumption will be high and which cases will be low.
uh, so we have seen that simple
Simple
clock
Claude
cycle is
cycle.
more.
Simple
Simple
Claude
clock
cycle
cycle
is
was more. More.
simple Claude cycle is more. Okay. So
Yes, something
dual pressure
16
Claude cycle will be something little lower.
less, less.
Okay.
But Linde Hampson was about 12 and that can be reduced to 6.66. That I remember.
Okay. Ha. Actually, what happened is Linde-Hampson cycle, the specific energy is 16.24. Okay.
Yes.
16.24. And the dual pressure Claude cycle, the 6.66. Lowest. This is the lowest one. This is the dual pressure Claude cycle.
Okay.
Okay.
So
Just
is it 16 by the answer is B or C?
answer is B.
Okay.
Answer is B. 16.24 and 6.66.
Okay.
This value you can remember from the
Yes, yes. It is only to
uh,
remember. Yeah.
it is also you have to remember actually. Okay.
Hmm.
Okay. This is all about the today's class. I will also have some more slide for your understanding. You can, if you want to go to in
Okay.
details,
So
you can.
are you giving us this in PDF? PDF
Yeah,
is
yeah,
better than the video, actually,
yeah,
what I understand.
yeah. I have already shared the PDF in the Google Drive. You can access the Google Drive. You can mix access the Google Drive. You will find the my PDF. Okay.
Okay, okay, okay.
Okay. You will download the PDF and you will better understand whatever we have studied here.
Hmm.
Okay.
Okay, okay. Thank you.
Okay.
And
Thank you. Thank you.
yes, and regarding that question, actually, that in the assignment 7,
Okay.
so yeah, so is it
Yeah.
we
Assignment 7.
everybody?
Okay.
Yeah, in the
Assignment 7, whatever the data I am getting and whatever the that student
answer.
had share, I mean, Apurvo, what the name, Arup, what are the students?
No, no. Actually, I shared first. I shared first, and I shared my that that working also the how I did it.
Uh,
So and everybody share that their answer also same.
yeah, my
So
answer is also coming the same, and
same.
this
But
is the correct. Asim Kumar, what has
yes,
shared?
yes, I
Yeah,
yes myself. I
yeah,
shared it.
yeah.
But
This is the correct process. I have checked all the things, but there is totally correct things. I'm not getting the all the things. You have done very well, because there is a aim that is the for the 2 kg of hydrogen, the total moles will be 2 kg means 2000 gram divided by 2 equals to 1000 mole of hydrogen. For the 1000 mole of hydrogen, just to multiply the 1000, it will come out in the form of kilojoule. Okay, that is very correct,
yes, yes,
whatever I
and
am
it's
getting.
very simple also because in last class you heard you have discussed. I mean,
Yeah,
you explained very well. So
yeah.
accordingly we did. But now, if we want to tell them how to do this, so we should
Yeah,
we should tell them.
yeah, you can send one mail. You can send
Mhm.
one mail. They how the by writing this such a way that what will be the correct answer, but by using the formula, we are getting this value. How the answer is coming? Can you please
Yes, yes.
give some
Okay.
the right options, or is it correct option? Correct option is B or C.
Okay. Okay.
Just politely you can write, and whatever the answer they will suggest you, they will give you.
Okay. Okay, sir.
Actually,
Thank you.
okay,
Thank
okay,
you.
okay,
Good
okay,
night.
okay. Thank you so much. Okay, thank you for attending the classes, and we'll see in the next classes next
Okay.
Tuesday.